Okay. It should now be working. Okay.
Well,
it is. Okay.
It should now be working.
Okay, there it goes.
It is. Okay.
Let's see. I need to adjust my OBS a little bit because I'm peaking. Let's see. Is that needs to come down a little more?
It's repeating on the live stream.
A little more. A little more.
No, it's not.
Maybe right about there. We'll see how that does. All right, now we're back. We had a little kerfuffle with our audio. For some reason, OBS wasn't picking up the my audio for some reason. But anyway, we are back with episode 2 of our CAD tutorial on Fusion 360 and Ondsel. In between episode 1 and 2, I actually downloaded Ondsel onto my computer here, so I'll be able to play around with it a little bit. We'll see
Just
how.
to let you know right now, on the stream, it is just a black screen saying stream starting soon.
Yes, I know.
Oh, intentional. Good.
All right, so you want to go ahead and get your screen share set up through the Discord?
I am.
And I'm gonna go
right
ahead
now.
and dive us straight back into Fusion 360 while you do that.
All right, that sounds good.
So let me turn down this audio just a touch more.
So,
Okay.
for the viewers who are probably wondering about last episode and the continuation into this one, the resolution is still around 720p. Is that something we're going to have to address in the future? And should we go ahead and let them know that we're on it?
Yeah, we got to figure out something. We tried to use screen share through Microsoft Teams, but the resolution was still lower. It looks like it was also 720p, and it also looked like the streaming bit rate was a lot lower than Discord's, so it was kind of low resolution and the kind of blurry you get with a lower bit rate. So we're gonna have to figure something else out moving forward, but for this one we're gonna be doing screen share through Discord again. So in the last episode we talked about just the bare bone basics of what CAD is, how it relates to 3D printing, the difference between CAD and 3D modeling software, and then we modeled a simple dish in Fusion 360 and talked about the basic tools and everything in Fusion 360 and I mean just CAD software in general. Sorry, I got distracted by my phone. And so, here is the dish we made, using a sketch, a revolve, and some fillets. And in this episode, we're going to be looking at text, how to create 3-dimensional text, and then how to emboss text onto a part, both on like a flat face and a curved face. And then I think what I'm gonna do is I want to talk about a couple new tools. So I think today I'm gonna try to hit on loft and then shell, and we're gonna model just a simple like house lamp, like a table lamp. We're gonna do a lamp base and a lamp shade. And for the shade, the lamp shade, we're gonna use loft and shell. So
I'm looking on my stuff right now, trying to find what that is.
Oh, yeah, what did we what did we figure out extrude was called in Ondsel? Pad?
Padding, yeah. To
Padding.
pad some.
All right, so I got Ondsel pulled up here. You said Ondsel was a reskin of FreeCAD?
That's the best of my knowledge, that's correct.
All right, I've never used FreeCAD, so I'm not familiar with it, but I will say these buttons are looking a lot like Inventor / SolidWorks to me right here. So just like with any CAD software, create a part. Yeah, I want to make a part. All right.
So for reference, if you look down in the bottom right of that screen, there's going to be 3 tabs, and the middle one says Blender, and I believe that is to have the same control mapping as someone who would be familiar with Blender.
Yes. So let's see. In Fusion, middle mouse click is pan. So I want to do CAD. Yeah, pan. Ooh, that's not right. Ooh, what is that? Ooh.
Pan, I click the right and left click at the same time.
How do I rotate? How do I rotate my camera?
Scroll wheel was doing that by clicking down. Or center mouse click.
Open Inventor? No, what is this? Take CAD.
Well, I mean, in fairness, you don't have any planes open right now.
Here we go. That's what I want. Revit. These are the controls. I want middle mouse click to be pan and shift middle mouse click to be rotate. That's the control scheme I'm used to.
Gotcha.
All right, so I want to fuss around in Ondsel just real quick. So in the last episode, we made this dish in Fusion 360 with a sketch, a revolve, and then 3 fillets to get all the edges. So I'm gonna see. I have never used Ondsel before. Never used FreeCAD either. So I'm completely unfamiliar with this, but I told it I wanted to make a new part, and then if I hover over it, okay, yeah, it just takes a second. Okay, create a sketch, nothing. Okay, so this is a lot more like SolidWorks or Solid Edge. So I want it on the XY plane. Okay, now I'm in the sketch view.
Hey, it would help. It'll help me if you share your screen on Discord so I can see you live instead of delayed on the stream.
Oh, I forgot to do that. Oops. Teehee.
No worries.
Oh yeah. Jeez, what? Okie dokie. Wait, where is your screen? Wait.
I'm only seeing me right now.
I only see me. What is happening?
Ooh.
Okay, there we go. I can see your screen now.
Well, I've got to figure out why I can't see yours.
Oh, hover over my name on the left and hit watch stream. That's how I got yours.
Oh, right. Great. I'm loving the lo-fi.
All right, I am going back to Ondsel. Okay, so I'm going to see how would I model the same dish in Ondsel. So this is now going to be a real quick Ondsel tutorial from somebody who's never used it. So I'm in the sketch view right now, making a 2D sketch. We got a few different line tools, polyline, arc. Okay, so I want a polyline. There is no grid. Why is there not a grid?
Definitely a grid in sketch view. I'm not sure why it's not on for you. Maybe it was something I had to set up initially in presets or in preferences. I'm sorry, but I can't recall.
What am I looking at here? Let's see. Sketch. Visual.
I would assume it's in the view tab.
No view.
Is that called the toggle axis cross?
Where do you see that?
In the view tab, in the view drop down.
That's grayed out for me. I can't do that. Let's see. Workbench, toolbars, panels.
Well, don't worry, it didn't do what I wanted it to either. Oh no, that brings up those little small bars you see like in a slicer, the X, Y, and Z origin, and then the little arrows, the red, green, and blue. I thought I did. Let me check.
Wait, hold on.
Preferences.
I found it. Wait. What? Huh?
Measure, appearance. No, you're right. I think it was on the front somewhere.
What is... Okay, well, this is organic. I can't figure out how to... What? Huh? Close.
Okay, it is the icon that is the green lattice that looks like
yeah. So I don't understand.
Get into the sketch. Double click on the sketch and then see if you can turn it on.
New sketch. XY plane.
Then click OK.
I'm looking at what these other settings do. Okay, click OK.
Are you zoomed in too far or too far out?
No.
Okay.
So, okay. I want to make a line. So I click it. I have the line tool. Is it my control scheme? What control scheme do you use? Do you have it?
I'm using Blender.
Okay, I'm gonna go back to Blender. And I'm gonna see.
Right now.
Nope, yeah, that wasn't it. That wasn't it.
No, I think it's the way you started, which just may mean that because I was trying to interpret some things that were a little bit different. Go to create a new. I'm gonna do the same thing with you.
Where?
Just open up a new, close this out and open up a new document.
All right.
File new. And then now that when you're in file new, just for a completely fresh document, go straight to clicking is it the red and white one? Is that it? Yeah, the red and white icon that says create sketch.
Yes.
That's what you should. Is that what you got before? I didn't see.
No. Wait, why does this look different now?
You need to have that. Click on the XY plane, and that'll should give you your grid.
Wait. Create a part with the part design workbench.
To follow your workflow and how you were teaching me, I figured that this was the correct way to do it.
Parametric. Create a 2D draft with a draft. Wait.
So you're about to show me something different. I'm trying to follow. Which is good, because I needed somebody with a flashlight in this forest.
Wait, why? I think
this is how it works. You have to pick the plane you want to be on.
No, yeah, you do. This wasn't how it was working a second ago. Like, I don't know if I encountered a bug. Why can't I click on this? Okay, now.
From what I remember, when I did it, you clicked create a part before you created a sketch, and that's why you didn't get to see anything. But you know more, maybe that it should be able to do both, and I don't know that.
Just a second ago when I was in Ondsel, yeah, I wanted to make a part. You're either gonna make a part or you're gonna make an assembly, and right now we're making a part. So like I did that to try to open up the thing, and then I went to do a sketch, and this
didn't show up.
This did not show up. I think I encountered some form of a bug or something. I don't know what that was. Yeah, so now it seems like it's working properly. Okay, so I want to change my controls. Yeah, Revit, that's what I want. Okay. Train got off the rails a little bit there, but we're back.
No, we told them this would happen. We're messing with stuff that we don't we're not familiar with. So
I'm blaming the software.
Okay.
That wasn't my fault. I know what I'm doing.
I feel you. Okay.
Anyway, so back on it. We're in the sketch thing. We got the grid now, and then polyline. That's just going to be your simple line tool. Start at the origin. Just going to draw this out the same way I did. Ooh, the zoom controls are inverted from what I'm used to. So it doesn't look like I have any automatic. Oh, yes, I do. Okay. Yeah,
What are you doing to be automatic?
Okay, so if you look at my cursor, it has the red symbol next to it. That tells me that I'm using the polyline tool. And then you'll see right now it's just the one red symbol. And then pay attention. When I get this line close to horizontal, it's snapped to horizontal, and then another little red line symbol popped up. Can you see that?
Yeah, it's happening for me too. I just got it. Let me know. I'm making a vertical line right now.
That means that's telling you, so for this, that's the symbol for horizontal. And then if I get vertical, it gives me a vertical line. That's telling you that when I click to draw this line, it's going to give it either a vertical or a horizontal constraint. So meaning that line will be constrained vertical or horizontal.
Nice. Okay, good. Good.
So, yeah, there we go. All right, I got my shape. Right click. Yep, right click. Got rid of it. Cool. All right, so I got my L bracket shape. Ooh. Yeah, this is a lot like Solid Edge. All of my homies hate Solid Edge. I'm gonna keep saying that.
Oh no, I'm using the tough stuff.
All right, so I drew my shape. Now I got to figure out it's semi-constrained, but I want to dimension it. So I'm gonna look up here at the toolbar. What is this? Construction. Okay, construction. Oh, I haven't even told you about construction geometry yet. That's crazy. There it is. Dimension right here. It looks like a little. It looks like a little ruler / angle finder. So dimension. Now I'm gonna dimension my.
Wait. Oh no. What if I don't see what you? No, wait. Do I? There it is. Dimension. I got it.
Yeah.
What do I do with it?
Click on it.
And.
So.
Okay, I have it active.
Yep. And then you click on what you want to dimension. So I want to set the length of the lines we're working with. So I set that to 20, but it's supposed to be 5.
Did you click on the points or the line?
No, you should be able to just click on the line. It'll highlight it blue before you click on it, and then when you click on it, lets you dimension it.
And I want to set it to what?
What are we doing? 5mm thick walls.
Yeah.
Yeah, this ain't so bad. Okay, now it's green. So that means my sketch is fully constrained. All right. So now that I've got that done, let's see. What do these buttons do up here? Sketch, leave sketch. That's leave sketch. Yeah, leave sketch. All right, now I'm looking at my sketch here. And we've got the CAD revolution. It automatically did it for me. All right. All right. And then, there it is. Fill it.
Oh, I have that turned on. That seems strange.
5. Yes. Okay. Failed. Wait. Wait, what? Why? Wait, why did it fail? I'm confused. It's weird. I don't understand why that happened. Wait, what? Oh, okay. So
Yeah. Okay. So when you were telling me that earlier, I know what you're having a problem with the
Yes.
fillets not meeting because you went 2.5 on a 5 and they're touching. So I think you
Yes.
have to go 2.25.
So in Fusion, the code, the algorithm for the part design, the part geometry is smart enough to understand that on a 5mm thick wall, if you put 2.5mm radius fillets on each corner, to automatically combine them into one seamless 5mm radius arc. But it looks like Ondsel is not smart enough to detect that and do that automatically. Which, to be frank, is kind of
Go ahead, hit me.
a bit of, well, I don't know what to call it, a drawback, a con, you know? Like,
Yeah.
So like you just can't do that, I guess, with the fillet tool, which sucks.
But I can work around that with the 2.25, and it still means that with the Ondsel, I'm able to, as opposed to the free version of Fusion, I don't have to have a low poly export.
Yes.
Right. I mean, that's my trade-off.
Yeah. All right. Well, anyway, so let's just cancel, edit this edge, just make it 2mm. Okay. It didn't do what I wanted it to. What? There we go. Okay.
I have just made this like very sexy dish. I'd eat out of this.
2mm, it's 5mm thick, 7mm. All right, that wasn't so hard. Just made the same dish again. How's yours looking?
You know, like a thing. Mine looks not bad, really. I don't think it does not look like yours. But not far from yours, really. Maybe not far at all. I put a 7.25 fillet on the bottom outside.
Mm-hmm.
Okay, well then that's right. Then I might be. You got a 20mm high wall.
Yeah.
I mean, maybe we got the same thing going right now, man.
All right, cool. All right, so I'm gonna hop us back over into Fusion. So that was a little bit of Ondsel, since we gave Fusion some favoritism in the last video. So that was a little bit more of Ondsel. So in Fusion, I'm going to open up a new part. And I am going to do some simple text stuff real quick. So you following along with me, Will?
I was kind of hoping that you would try to do a text thing first in Ondsel to let me know if I could even do it. It would be stupid of me.
All right.
I didn't know that. I didn't know that I couldn't.
Okay, so let's see. I want a parametric part. Okay, so I'll start in Ondsel. So basically, the way text works in CAD is you're going to do your text like you would a sketch. So I'm gonna go and do new sketch, XY plane. Then I want to look for the text. There should be a text tool somewhere.
There's added text document. That's all I've seen so far. And that would be in the tools dropdown.
I don't think that's what we want. Maybe it is possible that this won't do text, or at least not like that. Okay. Might have to figure that out later. So I'm gonna jump back over to Fusion. So here's how it works in Fusion.
Okay.
We got a new part going here. I'm gonna create my sketch. And then this applies for any alphanumeric text, anything you can type on a keyboard. So you go to create your sketch, you click the create drop down, select text, and you can either do just a regular like text box, or you can do text on a path. And I'm gonna do the regular text box first. So actually, I'm gonna do something else. So I'm gonna draw a rectangle that is 100 by 50 millimeters. I'm just gonna extrude it out 5 millimeters thick. Super quick here. I'm gonna put a little 50 by 20. Extrude that in a millimeter. Okay, so I've got this little simple rectangle thing here with a little rectangular cutout in the center. Let's say that this was just a lid for something that I was designing. Like I just made an enclosure for something, and I have this lid, and I want to put some text in this little sunken region that I've got here. So I'm gonna make a sketch, select the little sunken region in here, and now I'm gonna pull back up that text tool I was just in, and I'm gonna do the regular one. And I'm defining a text box to start with, and so I gotta define 2 corners for it, and I want all of my text to fit within this little rectangle that I made here. So I'm gonna go from one corner to the other corner. And now my text box, it's a little hard to see. Fusion redid their color scheme in a recent update about a month or 2 ago, or maybe less than that, and they changed some of their colors of some of their stuff, and honestly, I think it made a lot of stuff a lot harder to see. Like, you can't see, but there is a orange dashed construction line outline here now. But anyway, so I'm just gonna call this like box 01. So there's my text. I want it to be centered, so I'm gonna use the align tools just like you would in a text editor. And then I can tell it what font I want. I'm gonna see, I should have our font in here. Actually, I may not want to do that. What's the font everybody loves?
There's a bunch of fonts that I love. What do you want me to pick one
This
for you?
one, Comic Sans.
No one loves that. Why would you're being facetious.
Comic Sans. All right, and then you can set your character height. Right now they're set to 10 millimeters, and that looks like a good size for this box. It all fits. And then you can do character spacing you define it as a percentage. That's basically your kerning. So if I set that to 1, it's going to increase it by 1%, I think. If I do 150.
That's called tracking. What you're doing.
Okay, never mind. I thought kerning referred to the space in between characters, letters.
You are correct. It is the space in between 2 particular characters. When you do spacing in between all of them, it's called tracking. And it looks like you just did it between all of them at once.
All right, fair enough. Anyway, and then I can do bold, italics, etc. You get the point. So there's my text. I've got it where I want it. Now I'm going to hit OK. So now I have my text, and I can double click on it to bring back up the text window to edit it. But if I hit finish sketch and I go to extrude, I cannot.
That makes me sad. Oh, you can. They changed that for you, didn't they? Is that an update?
Oh, that's new. I don't know when that got added, but that is new. So previously, what you used to have to do was right click, hit explode text, which turns it into
that's called text to outlines.
Yeah, it turns it into like your geometric features. So like it turned that font into a series of lines and arcs and splines, but I can no longer edit the text. So previously In Fusion, you had to do that in order to do anything three-dimensional with it, to select it and extrude with it. But the catch was that once you explode your text, you can't edit it without undoing it. But it looks like at some point, I had no idea they added this. They changed it, so now you can select it.
Wait, okay, question. Does that mean that you can still edit it on the fly? So now it's more like I don't know.
We're about to find out. Okay, so I made my text. I want to extrude it in 0.4 millimeters. So that's in 3D printing. That would be 2 layers. So now it's in there. So let's see. Is that now revisable? Can I revise that? So this is now going to be box number 2.
2 layers because we're normally printing at 0.2 millimeter.
Wow. Yeah, 0.2. Yeah, 0.2 layer height. So 0.4 would be 2 layers. This is insane. I have been using Fusion for years and years and years. If this isn't new, I look like such a dummy right now. I swear.
It doesn't matter if it's new to you.
I swear, this is new. This is new. This did not used to be a thing you could do.
Nice.
Anyway, so that's how you do really simple, basic text. So I'm going to hide my little rectangular body here. And
that looks very easy for Fusion to handle.
Yes. I'm going to now... I'm going to draw a circle. So I have a 100 millimeter circle. Then I'm going to draw a 50 millimeter circle. I'm going to extrude it 5 millimeters. So I've got this washer shaped thing. And I want there to be some text along the top of it here, curved. So I'm going to go put a sketch on top of it. And I want it to be in the center. So, this is where construction geometry comes into play. So in CAD, construction geometry just refers to, in a sketch, any geometry you draw that isn't going to be taken into consideration for the actual like defined features of your part. So basically, like, let me hide this and do a why is it being weird? I have a sketch turned on. Let me do a new sketch. Okay, so if I draw a rectangle, this is a regular rectangle. The lines are solid and it has a defined space within it. And these are regular lines and they're defining this rectangle, and it has an enclosed profile that I can then go and extrude into a cube, right? But if I hit undo, if I delete this rectangle and I turn on construction geometry, so in Fusion the keyboard shortcut for that is X. You can see it over here turning blue. So you turn the line type to construction, and now I draw a rectangle. It's made up, man, see, they changed their color scheme. Now things are harder to see. So it's this orange dashed line. The rectangle is still there, but you can see it's no longer an enclosed profile within it because it's made of construction geometry. So the construction geometry is just there to provide a reference. Let me finish this sketch. Delete this, I don't need it. So if I go back to my little rectangle that I just drew, I go back to this sketch right here. So in here, I drew a construction line across the center of the box because I wanted this smaller box, the smaller rectangle that I drew inside of it, to be in the center. So I drew a single construction line from one midpoint to the other midpoint. And then I drew a center point defined rectangle on the midpoint of that line. So this rectangle is constrained to always be in the center of this larger rectangle. No matter how I change the dimensions of the larger rectangle, the smaller one will always be in the center. So that's what construction geometry is for. This center line here I can use as a reference guide for constraining this rectangle, but it's not actually like going into part of the part. It's kind of, this is not a great analogy, but it's kind of like rulers in like Photoshop.
Okay. It's a reference point.
Yeah, so that's construction geometry. So I got this disc shape here, or this washer shape here. So I'm going to go back to the sketch that I started, and I'm going to turn on construction, and I want a circle. I'm going to use offset. So actually, I said I wanted it to be centered between these. So if I draw another circle right here, there's a few ways you can do this, but I believe if I draw this circle and then I use the symmetry constraint, I should be able to click on... Wait, hold on. I go... Number 1, this... No, you may not be able to use symmetry with circles. I don't think you can actually. Okay. Never mind. So I'm just gonna use the offset tool. So I'm gonna click offset. I want it to be 25. No, divided by 2. 12.5. Okay. So here is, I want my text to be along the curve here, this circle here. So I go back to the text tool, and then I do text on a path, and it can be any path. It could be a spline or an arc, or it could just be a straight line. But for this circle is our path, and so because we have the full circle here, we're a little bit limited within the text editor for the placement of the text. So we want to go back and do a better job setting up where we want our text to be, because I want it to be on the top half here. So I'm going to draw some construction lines here, and then I'm going to use the trim tool to trim off. So the trim tool trims your sketch geometry from one fixed point to the next fixed point. So I just drew these 2 additional lines here that creates a fixed point here and a fixed point here on this circle. So if I select trim and I trim it, it now trimmed off the bottom of the circle, and I'm left with just the top. And you'll notice that when it did that, it deleted that dimension because it deleted that constraint, basically. So I personally don't like using the trim tool because I don't like having to deal with going back and reconstraining things that I've already constrained, because I just find that kind of annoying. So I usually try to do other things, but for this, I can just redefine its radius and we'll be fine. So now I should not have left the sketch.
You would do well in Illustrator.
Text on path, select the path. Now it's centering it up on the top because I know it knows I want it on the top. And I want to flip it vertically. No, I don't.
That A with the line on it is usually to flip it to the other axis. There.
Yeah, but this is not. This is
That's on
okay.
track anyway.
This is not what I want. So flip it horizontally and vertically. That's what I want. Okay, there we go.
I was thinking your line was going to have to be offset by about 75% of the way.
Yeah,
that's
so
not bad,
I
huh?
thought that you could center it on the path, but it's either above or below.
Yeah, to my
So-
knowledge, the at least in Illustrator, if this is anything like it, which is starting to look like it, there is no metadata within font files for the center along the source of a text. It's either cap height or baseline, and that's why they always work that way. But you can adjust that circle you made and then center that way.
Yeah, you are correct. Okay. Yeah, text is always a little bit finicky with stuff like this. Just because that's actually a really good point from a perspective that I never thought of, because I think you know a little bit more about text and fonts than I do from your graphic design experience. But
now you know why the front door graphic was becoming a little bit of a headache. Some stuff like this right here.
So since it doesn't know where the center of the text is, constraining it to be centered can be a bit tricky. But for the scope of this, we're just gonna slap it on top and call it a day. So this is circle 01. Hit OK. Finish up my
Now-
sketch. Yeah.
Question: Can you select everything you have right there and then just drag to duplicate? Is that an option? Because that's an intuitive thing for me. If not, I'll have to learn the other way.
What do you mean?
Like you've got a washer there right now that says circle 1. Can
Yes.
you select that and then to the right of it create circle 2? Can you just duplicate everything you have there over to the right?
Let me So now we're getting into patterns. That would be a pattern or a mirror. You would either do a pattern or a mirror to do that.
Okay.
So you
I'm thinking that's not the way CAD works. It's not supposed to allow you to do that, but I was curious if it could.
Yeah, so you go to create and pattern, and I'm just going to show a rectangular pattern real quick. So I select the rectangular pattern tool, and you tell it what you want to be patterning. Anyway, and I just want to pattern the body. So I was doing that on purpose to try to be funny. That wasn't funny.
Okay.
Anyway, I select the body,
That was even better.
and then you tell it what axes you want to pattern on, and then I'm just gonna drag until it looks nice. So, it's green. Man, I'm telling you, Fusion redid their color scheme, and I am not a happy camper about it. It did not used to be this hideous green. Anyway.
I don't know. I kind of like it. I mean, but then again, that's like what you say. It's what I'm being introduced to right now, so it just feels right to me.
Yeah, so I hit OK. Now I've got 9 washers that are all identical.
Are they linked together, and if they are grouped so they mirror each other, or can you individually edit them? Would that be a way for someone to make nine washers, call them circles 1 through 9 pretty quickly?
No, they're all linked together.
Okay. But that's a nice way to get a file set up here. Well, I mean, you could do multiply in a slicer and probably get the same result.
Yes.
But I wanted to see it say 01 through say 09 in this instance.
No, there is not a easy, intuitive way to do that. Not in Fusion, at least.
Get on it, Fusion. You heard it here first.
Okay, so that's text. On a 2D plane, both with a regular text box and then text on a path. But let's save. What if I want to put my what?
Go ahead.
What if I want to put my pet's name on my little dish here along the not 2D plane, but the curved surface? So that would be text wrapping. And I actually have to remember how to do it in Fusion because I haven't had to do it in a while. So I believe that we would use the emboss tool. I really gotta remember how to do this. So I think what we'll do is we want to draw our text on a plane on this that's tangential to this curved surface. So I will go to construct to create new construction geometry. I'm going to do a tangent plane. And I want
Does that mean you're going to create a flat surface like I see with the yellow right there, but when it gets done, it's going to map itself to the linked surface, which is the blue wall or that face?
Not quite. It creates a flat surface that is tangent to this circle. Meaning, so tangent means that this line touches this circle at one point and only one point.
Okay.
So if you have a line that goes through, this is geometry. If you have a line that goes through a circle, there are only two possible ways that line can intersect with that circle. It's either going to intersect with it at 2 points or 1 point. And 1 point being tangential. If it's hitting it either more or less than 1 point, it's either not touching the circle or it's going through two spots of the circle, if that makes sense.
Bisect, no. Is that bisect? It's intersecting. It's not though. It's tangential because it's technically touching it at 1 point only.
Yeah. So this is how you would put this plane to be on the surface of this edge, because if it intersected with it with more than 1 point, it would be like inside the surface, if that makes sense.
Yeah, it's looking like the way someone would start making a ring to me. I mean, I'm just looking at a use case.
So now we've got a flat surface here to start our sketch on. So I'm going to go to create sketch, choose this plane, and now we're going to use project to project the flat 2D geometry of this cylinder onto the planes. So this is a good example of how project works. You see what I'm...
I think I got an idea what's going to happen. You've just made a lens to basically like a projector, which is going to take whatever we type on that plane, and it's going to automatically map it to what's behind it.
Yes. So I want to fill this in, make a full rectangle. Now I'm going to use a construction line to go through the center to get the center. And I'm going to draw a center point rectangle in here that is 15, no, 12. That looks good. By 50, 60. There we go. So this is where I want my text. I'm going to make that all construction geometry as well, because I just need it for reference. So this is where my text is going to go. Then what are we putting here, Will?
Let's throw down cookie.
Alright, I gotta
Hey, that looks pretty darn centered. I was fixing to say, I bet you can I wonder if you can center on it so it's a box instead of a line. So the box does let you do all that. It's got the standard paragraph formatting.
Yeah.
So it's centered.
Yeah. So I'm gonna go ahead and explode it, because I think I might need to use the emboss tool. I may or may not, but I'm just gonna hit finish. Actually, I'm gonna Work with me here. What's happening? There we go. I'm gonna turn that. I just don't want that to be. Okay. So now we have our text here in front of our curved surface that we want it to go on. And yeah, it is like a projector. Like we're about to project it onto it using the emboss tool. So we select the emboss tool. Now it's telling us we need to select the profiles we want to emboss over here on the right. So we're going to select all of these profiles. And then we need to tell it what face we want to emboss. So we're going to why is it doing that? Okay. Select the face. And now you can either emboss outwards, so you add material, or you can deboss, which would be cutting inwards, which would be removing material. Typically, and this is true for honestly most manufacturing processes, but especially 3D printing, like FDM 3D printing and injection molding. When you're doing text like this specific type of thing, it's better to deboss it, so cut it into the wall, than it is to emboss it, so having it protrude from the wall, just because aesthetically, visually, it's going to look better. It's going to, in terms of like its manufacturer quality, it's going to turn out better, and it's going to be less likely to get messed up or damaged over time. So just in this type of part design for what we're doing right here, like putting text on something like this, it's better to do deboss and go into the wall. And for this, we're doing a 5mm thick wall, and you see that it's cutting into the wall 2mm. So basically the way this works is it's taking the silhouette of these profiles that are on this 2-dimensional plane, and it is projecting them onto this curved surface. And then once it gets that 2-dimensional silhouette onto the curved surface, it is then cutting into the 3-dimensional object perpendicular to the tangent of that 2-dimensional silhouette that's on the surface. So like what I mean by that, it's perpendicular to the tangent. What I mean is this E right here at the end of cookie, I'm looking at it perfectly vertically right now. The E right here is 2-dimensional in this plane, and it is being projected onto this curved surface. And so its silhouette is 2-dimensional in a tangential plane right here, and the cut you can see is going this way, and it's not going straight this way, which you might intuitively think it would. You may or may not, but it's smart enough to know that what we want is for it to cut in perpendicular to the tangent on the surface.
So all those lines that I'm seeing right now in the end cut, those are actually the points within the font as it's been defined to create the shape itself. And all of those points that are on the tangential surface are actually going to meet up. They are not parallel. They are all going to meet up at the center of that dish, which is the origin point. And that is what that tangential projection is.
Yes.
So technically, the furthest wall of the end cut is a replication of the font, the character from the outside, but it's actually smaller. It's scaling down because every bit, like that. Every bit you get closer to the origin point.
I might have just crashed my fusion. I shouldn't have done that. Yes, you are correct. They will meet at the origin because it is a circle. Yes. Oh, this is gonna crash.
Defeated by a cookie. No, it's all good. That's so. I was gonna say, well, go ahead. You go ahead and get that back up. I was trying to be the ADHD multitasker that I am sometimes, and I was looking, and there seems to be a way for me to go ahead and actually do text in Ondsel, and it has something to do with taking a shape and putting it into the draft workbench, and then creating the term that is being used is shape from text. But I will say that I have not been able to activate it while in the intermittencies. It was not working for me.
Okay, well,
Fusion is making it look much easier.
I lost all of that, so I'm gonna whip that back up real quick. So,
All right, no.
without having to re-explain how to do it, I can do this real quick. What did I do? 60 by like 12?
Now, that stream deck is looking pretty useful. I could have seen the audience or the air horn going off right then. Although that's gonna make me a live stream terror.
That's what we would have wanted.
Yep, that's
when
it.
When it crashed.
Yep.
Okay.
You know, is that oh god, it's such a bad font that I can't remember what it's called.
Comic Sans?
Yeah, is that Comic Sans right now?
Yeah.
Yeah, it actually works for the name Cookie. That's very few use cases for that font. But
So
a cute pet dish is one of them.
For this, 2 millimeters is a little bit deep, so we're gonna do something more like half a millimeter. Half a millimeter should be good.
At half a millimeter, would someone have to worry about supports when printing into this? If they were like this?
No.
Wouldn't would they?
No.
Cool.
No, not really. Not for this. You would get... So, one of the pros of using Comic Sans for this actually is the fact that the all of the round edges are actually pretty nice for 3D printing. So like the top of this K here, because it's rounded, it's an arch. Yep. It'll like support itself all the way up to the top. You know what I'm getting at? So you wouldn't need support. So like the only area where you might have a little issue with needing support material on this font here would be like maybe this spot on the C would probably droop a little bit.
What about the bottom of the negative space and the cookies in the O? The
K here, this sharp corner on the K would probably potentially droop a little bit, and then this E, this right here on the E might struggle a bit. The bottom of these O's potentially also maybe, but it's at half a millimeter coming out. It's so small. It should be okay. It should be able to bridge well enough. But there you go. So that's text. That's doing text in Fusion.
That is easy. Okay. Well, it's not easy to get there by myself. I appreciate that.
So, I just had to mute my mic because I had a coughing fit.
No worries.
All right, so we did text and boss text. All right, let's move on to. What do you think, Will? Do you have any
use case scenarios right now? Not entirely. I think I have some things to discuss with you after the show to see if they pan out correctly. But you were talking. Let me get to the correct place because I don't actually know how to do that myself. Oh man, let me go to my sketch. That'll help, and I'll probably see what I want to see. I have made this all upset with me. It's so easy for me to upset these programs. Is it TechDraw? I just want to see the original tools. Come on. Continue file. There was a thanks, man. There was a tool that you were talking about using, and I wanted to use it. I guess it's called the additive loft. We were gonna check into that. Lampshade style?
Yeah. I had my mic muted. Yeah, what about it? What?
I don't know. Is additive loft something you would use for like making funnels or ducting?
I'm sorry, say that again.
Is additive loft the kind of tool interface you would use to make like some kind of ducting for like air conditioning or
Potentially.
or a funnel even?
Potentially.
Oh, so it's like there's a couple ways to do this, and that's one of them.
Yes. So let me pull back up Fusion. Real simple. I'll just show you. So a loft is connecting two profiles to each other, and it kind of like interpolates the space in between to create the shape that you want. So this little tooltip right here actually does a very good job of showing what it is. So you have your square profile on bottom, and then your circular profile on top, and then the loft is creating the 3D volume that would be enclosed by combining those two profiles three-dimensionally. And you can define the way that it calculates that by either using a center line to guide it or rails, which would be on the outer edges. So I'll just show you real quick. Basically, I'll just do what the little tooltip shows. So I'll draw a center point rectangle that's 100 by 100. I'll finish that, and then I want to do a construction or an offset plane. I want to offset it 100 millimeters, so that's 100 millimeters up vertically. And now I want to do a sketch on it, and I want to draw a circle, also constrained by the origin. I want it to do 50 millimeters, so it's smaller than the square.
Yeah.
So now I've got a square down here, and then a circle 100 millimeters above it vertically. And I want to create a loft that goes in between them. So this is what it automatically does. It takes the four corners of the square, and it just draws a straight line to the most logical place to put it on the circle. And you can see I can actually grab the point, move it. It is a little bit difficult to tell, but
no, I know what's going on though.
This is also affecting the
shape of the object.
Yes.
You could technically do something like that and put a swirl on it. Somebody did, I'm sure.
Yeah, so yeah, see?
Yeah, that looks cool.
So that is what loft does.
Okay, that's wild. To me, that's pretty wild and a nice way. Definitely ductwork usage there. That's crazy. That's crazy.
So yeah, like you were saying, funnel. This would be a pretty easy way to make a funnel, that kind of thing. So with everything we've learned so far, we should be able to make a simple lamp pretty easily. So we're gonna start with the bottom of the lamp. I'm gonna go through this a little bit quicker because I've already talked about each of these tools individually, but I'm gonna start with a sketch. Go here. So I'm gonna revolve the base of the lamp. So I'm gonna draw a construction line, make it 100 millimeters tall. to be my axis that I'm going to revolve around, and then I'm going to draw the side profile of my lamp, about 25 millimeters. That's probably good. And I'm just going to use a fit point spline to just give it a organic lampy shape.
Okay, you're making a lamp base right now.
Yes. Yeah. I'm going to draw a line here to here. I want it to be perpendicular. There we go. All right. This actually needs to be a solid. Well, actually, no, there we go. That actually needs to be a solid line, not a construction line. So you'll notice this fit point spline is blue, meaning it is not fully constrained. The thing about splines is
they're more organic.
They are much more difficult to constrain. So I usually only use them for freeform stuff where I don't need it to be fully constrained per se, or I don't like. Honestly, most of the time, if I'm using a spline, it's because I'm trying to trace a 2D image of something, like that eagle logo I created.
Yeah.
Anyway, so this is my lamp base, and I'm gonna hit finish sketch, revolve. I messed up.
Now, when you say it's harder to constrain them, do you mean in the context of a parametric object, or just in general? If you went to scale this, they wouldn't hold this because they're Bezier curves. They should hold their formulaic values, I would assume. What is the part where they're harder to constrain? They have some constraint on them already, right? So, like, they're able to scale and stay in proportion to themselves in orientation, in negotiation with where each point is. They hold their shape, right?
Yes, but that's not what constrain means.
Gotcha.
So, I actually need to turn the lo-fi down a little bit so I can think a little clearer here. So what constrain means, let's take this vertical line, for example, because this is really simple. I have used the line tool to draw this object. So it is defined as being a straight line. It has a start. Sorry, my cats are acting a fool. It has a start point and an end point. And since I told it that it's a line, it knows that, well, there's only one way to get from point A to point B, and it's with a straight line. And then I also, it is vertically constrained. So I'm telling it that that line cannot be anything other than vertical. And then I have told it that it is 100 millimeters in length. So the start point is 100 millimeters away from the end point. So it is fully constrained. There is no other possible way that this line could exist and all of the things I just said remain true. There's only one mathematical answer to the formula that is this line, and that is a 100 millimeter long straight vertical line right here in the Cartesian space.
Okay. So it and the base are locked. They're good, at least to my knowledge. It's the outside that's not locked. What happens when you scale it, though? Are you saying that the base and the height, and for those watching, this is going to be revolved to become the base of a lamp. Are you saying that when you scale this, the outside of the lamp can get distorted, the actual shape, because we have the height and the base?
Okay, so you keep saying scale. If I scale it, everything's going to change in proportion.
Mm-hmm. Okay.
What I'm saying is, so you're saying if I were to scale it, everything would scale up proportionally, and it would all be fine. But if I were to come back and say I need it to be, instead of 100 millimeters tall, I need it to be 150 millimeters tall, Well, now it looks like this.
Okay, I definitely know what constrained means now.
And you'll notice I just changed it back to 100 millimeters, and I'm pretty sure. No, it did revert to how it was originally. Never mind. But anyway.
No, I get it. If it was constrained, it would be each point along that spline would be constrained to the next point, so it would all algorithmically adjust itself and stretch in unison. Like the difference between kerning and tracking. You're only messing with the kerning between 2 points instead of the tracking of all the points in tandem.
Yeah, kind of. So anyway, gonna revolve this. It automatically selected the profile because there's only one. I'm gonna select the axis. All right, so here's the base of our lamp.
Mm-hmm.
And
That's
then
a mighty fine lamp base.
Now we need I'm just gonna skip straight to the lamp shade. So, you would imagine, because to do the other bit of the lamp, where like the light bulb goes in, and then the actual light bulb, you could accomplish both of those using a revolve. So you could do it the same way. Actually, no, maybe I should do that.
You'll do that in the sketch, right?
Just for posterity. Yeah, so I'm gonna add another sketch right here. I'm gonna project this. And this is my lamp socket. So let's say here and here. I'm gonna draw a construction line for reference. I want these to be symmetrical about that center line. I want it to be 3 millimeters, 5 millimeters from the edge, and then oh, I forgot that I was revolving this. I didn't need to do that. It's late.
Oh yeah, you only need to make half of it, won't you?
Yeah. It's late and I am tired.
Will this inset into the base in the end? No, I know what you're doing. Never mind. You're adding on. This isn't going inside the base. This is being built on top of it. I get it.
Okay, there you go. So this is where your light bulb would screw in, basically,
Mm-hmm.
So there you go. And then now we need a lamp shade. So I want to start my lampshade on the two-dimensional plane that this little flat washer is on. So in Fusion, I can just click New Sketch, and I can just click on that flat surface, and it automatically puts it right there.
Oh wow!
So
in the idea of the height, you're already parallel on the z-axis with that point.
Yeah.
Yep. It's showing it to me right now.
Yep.
That's exactly where you are.
Yeah. So yeah, that's it. That's going to be the bottom of my lampshade. And then I want to do a construction plane. Go up to yeah, that looks good. Right there. And then I'm going to draw a sketch right there. And then that first circle was 70 millimeters. So this one, I'm going to say 45. Just to give it some character. Okay. Now, if I go and create a loft right now between... Well, first of all, with this body visible, it's a little bit difficult to select everything I want, but I need to select all three of these profiles. And then this profile, and you can see, so it's red. In Fusion, that means it's cutting. So let me unselect that profile. What it's doing is, since the profile is intersecting with a solid body, it thinks I want it to cut away all of the solid body that's being intersected. So if you look, where I did the little where the light bulb screws in, it thinks I want to cut that off.
Got it.
But that's not what I want to happen. I want to do, so you see the operation down here, it says cut. I want to do join. But if I do join, it's just going to turn this all into a solid and combine it with the rest of the lamp. And that geometry I just drew for where the light bulb screws in is going to be lost. So what I want to do is go over to my visibility tree here on the left, and I want to hide the body of the lamp. And now I can hit OK. And it's going to make the loft right here for the lampshade. I can turn the body back on, and this geometry is still here. So right now they're just intersecting with each other.
Yeah.
So to make this not a solid and more lampshady, that's where the shell tool comes in. Basically, it just hollows out the center of a three-dimensional shape and cuts out the wall that you select. So I want to cut out the top and the bottom, and I want the lampshade to be 3 millimeters, the wall to be 3 millimeters. That's actually looks kind of thick, so maybe 2 millimeters thick. So to make it more clear what that does, if I just select just the top, the bottom is still there.
Yeah.
Oh. So I want to do
That's a quick way to make a trash can.
top and bottom. Turn that back on. Now we have a lamp.
Man. What? Yeah, that's pretty wild. Okay. That is loft and shell. Loft
yeah.
and shell.
Yep.
Okay. Revolve, loft, and shell. Nice. I'm going to have to figure out how to recreate all three of these, especially the text. I feel that I can, and I'm going to catch up to you in these sessions and get something done. That's very nice. All right, man. So it's floating right now, but I get it. That would be you'd create the joinery for holding onto a light bulb by measuring the light bulb and then creating the pieces. Some of this would be pretty hard to 3D print. I mean, I assume for instance, a lampshade is like one of the hardest things to. No, I guess if you turned it upside down, it wouldn't be that bad, would it?
Nope.
You just need enough support built at the bottom of the top.
Now would be a fantastic time for a shameless plug. Actually, hold on. Will.
Yeah.
Keep them entertained while I do something.
Well, keep them entertained while you do. Well, I guess can I ask you some questions while you're doing whatever you're doing?
Yeah.
How exactly does one go about? My mind is thinking, since you've done this, and I've seen you heat set things before. It's possible for me to get some wires that would come from like a busted. Say someone's got a lamp and the lamp's been tattered and torn, and there's really nothing they could do with that anymore. The fabric's gone. It's dry rotted or whatever. It's just old, and they want to repurpose it. They could technically, I'm right in thinking they could technically 3D print this new lampshade and heat set in the wires from that old one directly into this. Kind of set it at the top, heat it up, and press it in. And and they could even put their kid's name on it, and by using the projection tool and pierce it all the way through the lampshade, so that a small amounts of light would come through the lampshade from the light bulb and project onto the room itself when the light's turned on. That'd be pretty cool. But how does one go about? Well, when you get the chance to answer this, I'd like to know if there's any do's or don'ts for someone who wants to create heat insets and take their filament prints and integrate it with, say, metal. Because I know we actually kind of do a little bit of that on a weekly basis. Well, maybe not a weekly basis, but we do it.
I'm going to answer your question. The shameless plug is live. If you want to 3D print your own lampshade like how we just modeled, you can go head on over to americanfilament.us/collections/lithophane PLA-AF and pick yourself up some lithophane PLA, perfect for 3D printing lampshades.
It actually is. You're right, because
that's what it's designed for.
That is absolutely what it's designed for.
There is a lithophane, a lampshade lithophane tool on the Lithophane Maker website.
So they could take any of their family images and print it onto the lampshade, or design it into the lampshade from the Lithophane Maker desktop application, and then have that actually come through from the lampshade.
Yep.
Perfect. Yep. Absolutely right.
All right. Beautiful. So you were asking about heat set doing the wires from a old lamp?
Yeah.
Yeah, I mean, if you heated them up and just pressed them in the plastic, yeah.
That's the easiest way. It's just press down.
Well, you'd probably have a more reliable, repeatable result by just designing a channel for the wire to snap into in the lampshade, rather than trying to heat it up and press it in.
Okay.
This is like how when you and Megan the other day were talking about how y'all have had to drill holes in 3D printed parts, and I was like, I don't think I've ever drilled a hole in a 3D printed part. It's because if I ever need a hole in a 3D print, I just design it in from the beginning. Like, I don't drill it in later. You know?
That makes good sense. Yeah, I get it. I mean, so can I open up? I know I can save out STLs. Can I open up STLs in my, like someone else's design? Could I open it up and edit it in modeling in the CAD software?
Yes. But I don't have a STL file conveniently located that I can open up easily. I'm
assuming
actually,
like all of it.
Let me do this. There we go. Now I can open it. I just didn't want to accidentally show something I shouldn't on stream. Go to personal. That's way too many. I can't do that one. I don't know if I have a... Sorry, bear with me here. Where is it? CAD tutorials. Okay, upload. Let me go find a STL file that I've got somewhere that I can use for this.
So this is a STL that's opening up.
That I'm trying to open up.
Yeah.
I'm uploading it to Fusion right now. I should be able to share my screen again. Okay. I took one of the STL files from my that articulating lamp. It's uploading right now. It's loading. I don't know why it's taking so long. Come on.
The blue bar.
Oh, now it loads as soon as I go to do something else. Thank you.
It was loaded the whole time. Yeah, I was just messing with you.
Anyway, I should be able to use this. Okay, so now we're getting into the difference between CAD and 3D modeling again. So we're getting into the solid body versus a mesh body. So an STL is a mesh body. It does not have all of the same data that a solid body does, and it is not defined the same way that a solid body is. So this lamp is a solid body. It is defined by a series of 2D geometric shapes that have been projected somehow into a third dimension, creating a 3D geometric shape, whether that be through an extrusion or a revolve. But they are defined based off of their like geometric shape or whatever. This mesh is defined by a series of points that are have a coordinate definition associated with them. So like this, it won't even let me select the individual points. But like,
oh wait, that's in fact a poly mesh then, isn't it? All triangles.
Yeah, this is an STL file. When you open it up straight into Fusion, it is a mesh body. So I cannot hit create sketch and select one of these flat faces to sketch on, because it is not a flat face. That's not how it's defined. It is a point here, a point here, a point here, and they're connected, but it's not the same. So
for those who are just tuning in, I'd like to let y'all know that what we're talking about right now is importing an STL, which is that say someone else has already uploaded, and we want to remix that file and figure out how to do that in OpenCAD in CAD software after the fact. We're looking at the limitations and working our way through the hangups.
Yeah. So in Fusion, if I want to take this STL and edit it, there are two things I can do. Up here in Fusion, you can in the design workspace, right now I'm in the solid workspace. I can go over here to the mesh workspace, and now I can work with the mesh tools. So now this is getting much closer to 3D modeling. And I only touch these if I have to. I know what all these tools do. I know when to use them, etc. But I prefer to stick in the solid workspace. So the other thing you can do is if you right click on the mesh body, it's not that. You go to mesh, where is it? Convert mesh. You should be able to right click on it.
think I say stuff like that inside of a piece of software every day, where I assume that it's it would be more intuitive if it worked that way. But
you used to be able to. They changed it at one point. This is another thing that got changed. You used to be able to right click it and it would show up in here. Anyway, so you go to your mesh tools, you go to modify, and you do convert mesh. And this is how you convert between a mesh and a solid body, or yeah. So I've got that. Click on the body, and I want to turn it into a solid body. And I'm going to try to do prismatic. A lot of times prismatic doesn't work well. Yeah, it failed. So what if I just do faceted? Yeah, there we go.
what would have been the advantage of prismatic since it was your first choice?
So let me turn the lo-fi down a little bit more again. So you see right here on this face how this is just a flat rectangular face, but it's broken into these two triangles.
Yep. It would have merged them, wouldn't it?
Yes, it would have been like, oh, this is a flat rectangular face. This just needs to be one defined profile, one flat rectangular profile. It would have merged the triangles.
Mm-hmm. That makes
and
sense.
It would have merged all of these triangles to make this one singular.
Now I can do something like what you're talking about in Illustrator. Can you do this after the fact by hand?
Do what?
Merge those triangles.
Yes, but it is slow and
it is. Yeah, you're right. Would have been better to import it the other way, but at least it can be done. That's the goal I'm looking for.
Yeah, so I know. Is it combined? Oh, actually, I can just I can do this. I can select them. Select them all. I'm holding down Control to select multiple, and then I just hit delete. Boom. It's actually not that bad. This isn't too bad because it's not too many triangles. So then here I could just do this. Delete. Yeah.
Oh, okay, that's intuitive. So then, and I think we owe the favor of that to Fusion for probably having the code on their back end of their software to be intuitive enough to know to do that.
Yep. The delete key is your friend.
Nice.
Delete.
You were holding Control to select all similar shapes, or
to collect. So I am not holding Control. I'm not clicking any keyboard keys. You see how it's selecting one?
Yeah.
And then now I'm holding Control.
Yeah, but I noticed that you were somehow when you just did that one section, it's most of the triangles in the pattern left.
The delete key is
perhaps all similar.
No, not exactly. The delete key is really smart sometimes. And
that's Fusion. Okay.
In this instance, it knew it was smart enough to know what I was trying to do. Sometimes that is a double-edged sword where it tries to figure out what you're doing, but it's not what you want it to do. So it kind of it's a double-edged sword basically, but in this instance it was helpful. So it actually made cleaning that up pretty quick and easy, really. So yeah, now this is a solid body that could be pretty easy to modify. So let's say I needed it to be a little longer. I can go up here and grab press pull, grab this face, yank it on up, hit OK. And now I have the part and it's just a bit longer.
And you can now anyone, so for whatever part they might have gotten off of a repository like printables could have done this, and now they can add it, how they can augment or remix the file however they need to.
Yep.
Okay, it was as easy as that. It was prismatic was the one we were hoping for, but we were able to solve that pretty easily in Fusion with the delete key. And what was the other option that we had to go for?
Other than
When you
the
import
delete key?
Other than prismatic.
Oh, faceted.
Faceted. Okay, and that brought it in as a poly mesh, or took the poly mesh and turned it into a solid body object that we could then work with.
Yeah.
And delete key handled the rest. Okay, so that's what I'll use.
Prismatic doesn't work if you have an advanced shape or a shape with a lot of triangles, that kind of thing. And this is like, this is not an advanced STL. This did not have that many triangles. Like, this shape was probably defined with like a few hundred, maybe a few thousand triangles at the most. And prismatic didn't work. Like, I don't know if I've ever gotten it to work. Usually the STLs you get for 3D printing files are gonna be like so large, so many triangles, that prismatic's just not gonna work. Because it's a lot for it to try to figure out. So like, I have let me cover my screen up so I can go dig through my files. I have a bust of myself that is a 3D scanned bust of myself. Let's see if I can even get it to open without crashing my software.
Yeah. I think you should tell people that the craziest part is that you used an Xbox to achieve that.
Well, not an Xbox, but an Xbox 360 Kinect. All right, here we go. I got it up. Close this.
You used the lidar from the Kinect of an Xbox 360, and I mean, that's pretty crazy.
Yeah, so I have this bust here of myself. It's a 3D scan. I used a Xbox 360 Kinect that I got off of eBay for $50. The Kinect has LiDAR in it, and I used a software on the computer called Skinect Pro to do this bust of myself. And this is a mesh, right? This is still a mesh. Yeah, this is a mesh. So if I zoom in, you can start to see all of the thousands of triangles that make up the surface definition of this part.
No kidding.
I think there's a way. So if I go to mesh, I go to modify, convert. I want to convert this. Yeah, it has more than 10,000 triangles. I thought there was a way for it to tell me.
Oh, it'll give you a poly count?
Yeah, to tell me how many triangles it is. Doesn't look like it. Mesh analysis, maybe? No. I don't know. I know it's like a few million, though.
I believe it. Wow.
So.
But so definitely prismatic would not work.
Not a chance. A lot of the mesh tools even really struggle, just because. So while Fusion can do mesh editing, and like I can have done like mesh editing like this in Fusion, like my bust here. It's not the best tool for the job. It can do it. It struggles pretty hard when you get to complex stuff like this file. Like it just lags and is slow. So
yeah, I would think Blender would probably be the place to go, right? I mean,
yes,
for a bust.
Yeah, I'm pretty sure Blender would handle this with ease. I think.
Gotcha.
But yeah, so
All right. That you just set me to sail, sir. I get it, and I'm gonna try playing around with that technique.
which one?
I'm gonna springboard off of some of the STLs that I have currently, and I'm gonna try this exact thing.
Okay.
And see what I can come up with. Now, as far as like the loft, there's a couple things that I think my dad asked me about a couple days ago that it's gonna come into play just fine, which is why I brought it up in the context I did.
Yeah.
Cool. We definitely should come up with the next topic, but I'm gonna ask you some stuff after we get off stream to see if we can come up with that.
Okay. Well, all right. Thank you to everybody for joining us. I think this is going to be it. We're going to wrap it up. And the VOD for this live stream should be on YouTube. If you are watching this from the future, before we have released the next episode, drop us a comment about what, if you have any questions, if we glossed over anything, need anything explained better, or want anything you want us to talk about next time.
But please keep it in mind that I'm a low level dummy when it comes to this stuff, and we're trying to build it up in sequence so that each new topic will build on itself. But I'd still love to hear if anybody else has real life issues they'd want to get solved, because that's exactly why we're doing this, is to achieve those goals.
All right. Thank you to everybody for joining us.